Factoring a quadratic trinomial with coefficient not equal to 1. I'm going to show you 4 different methods how to do this. So just as a reminder, a trinomial is a polynomial with 3 terms, and a quadratic is a polynomial where the degree is 2. That means the highest power is 2. So the general form of a quadratic is written as ax squared plus bx plus c, and in this video we'll talk about the case where a is a number bigger than 1. The first method we'll talk about is the Gcf factoring method. You should always try this one first. Then I'll show you another method called the reverse FOIL method, a third method called the AC method, which involves factoring by grouping, and then lastly I'll show you how to factor these quadratic trinomials using the calculator method, which will always work. Okay, in this example we have a quadratic trinomial with the leading coefficient 4, so it's bigger than 1, which makes it a little more difficult, and so we're going to try to factor out the Gcf. We'll open 2 sets of brackets and see if we can separate it into the Gcf in the first bracket and the leftover terms in the second bracket. And I look at each of the coefficients and I see that the Gcf in this case is 4. 4 divides evenly into all 3 of those terms. The first term, 4u squared divided by the Gcf that you factored out 4, that becomes just u squared. And the second term, minus 16u divided by 4 is minus 4u. Then the last term, minus 48 divided by 4 is minus 12. And we're not finished yet. We can break up that remaining trinomial into 2 binomials multiplied together, u times u. Now we just have to figure out what the last 2 terms will be. We list out all the choices of possibilities of 2 numbers that will multiply to be minus 12, and then they have to add to be minus 4. So if I look at my choices, I see those 2 numbers, and then I can say the remaining binomial terms will be u plus 2 and u minus 6. So we just rewrote the quadratic trinomial as a product of terms using the Gcf factoring method. Here is another example. Now I said before we should always try the Gcf method first, so we can ask ourselves, is there a Gcf? Is there a number that divides into 2 and minus 17 and 30? No, in this case, the only common factor is 1. So now, since that didn't work, we're going to try the reverse FOIL method. So I open 2 sets of brackets, and I think to myself, for the first terms in each pair of brackets, what would it take to multiply 2 things and get 2y squared? The only way to do that is to break up 2y squared into 2y times y. Now for the last 2 terms, we have to ask ourselves, what 2 terms will multiply to be positive 30? So I will list the choices. And now it's a little more difficult, but we must ask ourselves, 2 times this term, whatever that last term will be, plus, I'll put a 1 here, 1 times this term, whatever that term will be, must equal this middle term in the original trinomial. So it must equal minus 17. Only one of those pairs of factors from the list of choices will work in that equation, and it turns out that it's this one. If you put 2 times minus 6 plus 1 times minus 5, you will get minus 17, which is what we were looking for. So now we want 2 times minus 6 and 1 times minus 5. So there we go. We factored the trinomial into 2 binomials, 2y minus 5 times y minus 6. Okay, here is a third method. But before we start this third method, I want to remind everyone that you should always check to see if there's a Gcf first. So I look at the 3 coefficients, 8, 30, and 7, and I can't think of a number that is common to each, that's a common factor to each. The common factor is 1. So we can't factor out a GCF, and we need to factor this trinomial a different way. So in this third method, we look at the 3 coefficients, and step 1 is you want to multiply a times c. So in this case, that's going to be 8 times 7, which is 56. The second step is to take that number 56 and list all the factors. So here are all the factors listed out. These are all the pairs of numbers that multiply to be 56. So now step 3 says, looking at those pairs of numbers, figure out which ones add up to minus 30. So I'm looking at my pairs and I see this pair. So now that we know that, the next step, step 4, says rewrite the polynomial with 4 terms. So instead of writing minus 30z in the middle term, I'll write minus 2z minus 28z, which is equal. That adds up to minus 30. And now we can take these 4 terms and factor them by grouping. I like to put a plus sign in between there. So we'll factor the first group using the Gcf factoring. I see the Gcf in the first group is 2z. To find the remaining terms, I'll do 8z squared divided by 2z. 8 divided by 2 is 4. Z squared divided by z is just z. And then for the second term in this first group, minus 2 divided by 2 is minus 1. Z divided by z cancels, and there's no need to write it. For the second group, I can see that the greatest common factor is 7. But then just as a reminder, when the first term in that second group is negative, it's better to put the negative in the greatest common factor when you factor it out. And now for the remaining terms, the leftovers, minus 28z divided by minus 7 is 4z. And then 7 divided by minus 7 is minus 1. And we know we're on the right track when those leftover terms match. So our final step would be to factor out that common factor of 4z minus 1, which is a binomial that's in both of these terms. And then we write the leftovers in this case, which is 2z plus a minus 7 is just minus 7. That is our final answer. We took the trinomial, and using the AC method, we factored it into a binomial times a binomial. Okay, I'm actually going to do that same example another time, but now I'm going to show you how to use the calculator method, which is very popular with students because it's a lot faster. You take your calculator, your Casio calculator, and you press mode 5-3, and when you do that, you'll see A equals, and in this case, A equals 8. Then you type B equals minus 30 and C equals 7. When you type that in, the calculator will return 2 answers for you. The first answer it said from my calculator was x1 equals 7/2, and the second answer it says x2 equals 1/4. Now this is not the factored form. This is just 2 answers that the calculator spits out. These are called roots or solutions. We don't just want the roots or solutions, we actually want the factored form. We want 2 binomials. So here's how you get the binomials from the roots that the calculator gives us. First, you open 2 brackets. You ask yourself, what is the variable in the original trinomial? It's z in this case. So instead of x's, I will write z as part of my first term of each binomial. Then I will look at the denominator of each root. The denominator of the root becomes the coefficient of the binomial. And we do the same for the second binomial. The denominator of the root becomes the coefficient of the second binomial. And then the numerator of the root, the top number of the root, becomes the added or subtracted term. But the thing to remember is you reverse the sign. So here we have plus 7. So in the root, we make it minus 7. Here we have plus 1, so in the root we make it minus 1. Now if you rewind the video and you see the previous method and the previous example, it has the other term, or the terms listed in different order, but still equivalent. The previous answer we got was 4z minus 1 times 2z minus 7. It doesn't matter which order the binomials are listed, it's still a product of the same binomials and the same answer. Okay, so just in summary, use any method you want to factor trinomials when the leading coefficient is bigger than 1, but always remember to try to take out the GCF, the greatest common factor, first before using the other methods.